What's up, everybody? This is your boy Tech G back with another video. And today we're going to be talking about installing, configuring, and securing a basic wireless network. That is what we're going to be talking about today. So in this video, you will learn how to install, configure, and secure a basic wireless network. All right, so let's talk about 802-11A, B, G, N, and AC. So I know it sounds confusing, but I'll explain it in a second. So 802.11 and 802.11x refers to the family of specifications developed by the IEEE, which stands for the Institute of Electrical and Electronics Engineers, for wireless LAN or WLAN technology. 802.11 specifies an over-the-air interface between a wireless client and a base station or between two wireless clients. These standards are commonly known as Wi-Fi or wireless Ethernet. Any Wi-Fi device contains a radio, and like an AM/FM radio, the radio in a Wi-Fi has a specific range of frequencies it can tune into. Some versions of Wi-Fi use a series of radio frequencies starting at 2.4 gigahertz, while others use a series of radio frequencies starting at 5 gigahertz. Some devices support both ranges of frequencies. Either range of frequencies are divided into 20 megahertz wide channels that can sometimes be grouped or bonded together into 40 megahertz wide or 80 megahertz wide combinations. Not all Wi-Fi devices can connect with any Wi-Fi device. The reality is that there are two wireless frequency bands used for Wi-Fi, as well as differences in the numbers and width of wireless channels, differences in how signal interference is handled, and difference in security options. All of these factors must be taken into account, especially when you are adding wireless devices and network adapters to an existing network. All right, so let's talk about types of wireless hardware. So there are three types of wireless adapters currently available. You have add-on cards using PCIs or peripheral component interconnects, or PCIEs, which is PCI Express, and these are standard for desktop computers. Then you have USB adapters for use with USB 2.0 or 3.x ports. And then you have internal adapters in laptop or tablet computers. Laptop wireless adapters can sometimes be replaced or upgraded. So if you look at the pictures here, the one on your far left, that is an example of a PCIe Wi-Fi card for a desktop computer. The one in the middle is a typical USB wireless adapter, and the one on the right is a typical laptop wireless adapter. So we have a wireless access point, also known as a WAP or a wireless AP, and this thing adds wireless Ethernet support to an existing Ethernet network. A wireless router does what a wireless access point does, as well as it connects to a broadband modem for internet access. Most wireless routers also include an Ethernet switch, so you can connect both wireless and wired network devices to the internet. Let's talk about some older versus newer standards. So Wi-Fi can be divided into two categories: older and newer standards. Older standards include the 802.11b, 802.11a, and the 802.11g. All of these standards are out of date in terms of speed and, in some cases, security. Let's talk about the 802.11b. So the 802.11b, also known as Wireless B, was the first Ethernet standard to hit the market. It has a maximum speed of 11 megabits per second. It has only 3 non-overlapping channels and is difficult to configure for best performance when other 2.4 gigahertz wireless networks are present. Let's talk about the 802.11a, also known as Wireless A. It came to the market after the 802.11b, and it differs in the following ways. It has an easier configuration consisting of 12 non-overlapping channels due to using the 5 gigahertz frequency band, and it uses the 5 gigahertz frequency band. But because 802.11b and 802.11a are different frequencies, they cannot interconnect with each other unless dual frequency adapters or wireless access points and routers are used. Let's talk about the 802.11g, also known as wireless G, was designed to provide the speed of wireless A up to 54 megabits per second while enabling interconnection with 802.11b devices. Some 802.11g adapter cards and access points are dual band, also supporting 802.11a networks. Wireless G has the same limitations as wireless B due to the use of the crowded 2.4 gigahertz frequency band. The 2.4 gigahertz frequency band is used by other devices as well, which is why it is referred to as crowded. Some of those devices are Bluetooth devices, some older wireless phones, car alarm sensors, microwave ovens, some types of wireless cameras, some types of wireless microphones, and baby monitors. Newer standards include the 802.11n and the 802.11ac. In addition to faster performance, the 802.11n and the 802.11ac standards support more than one data stream so that more data can be transmitted or received at the same time. And here is a chart showing some of the newer 802 standards. All right, let's talk briefly about mixed mode. So if you want to use any device that supports 802.11b or 802.11g standards with the newer 802.11n and the 802.11ac standards, you will need to configure your access point or router to run in mixed mode. Mixed mode enables older and newer devices to run on the same network. Some routers may refer to a mode that supports the older 802.11b standard as legacy mode or BG protection mode. Let's talk about determining a standard to use. So, in order to determine which standard a wireless adapter supports is to view its properties. In Windows, you would use the device manager. To access the device manager, you click the search window next to the start button, search for device manager, and click the device manager in the control panel link in the search window. A faster way to access the device manager will be simply to hold down the Windows button on the keyboard and press X, then click the device manager from the menu. And that is what your typical device manager will look like. You will go in there, right click, hit the properties, and it will tell you exactly which standard to abide by. All right, let's talk about the 802.11n. So wireless N is the current minimum standard for equipment with Wi-Fi capabilities. Its standard version supports the same 2.4 gigahertz frequency band as its predecessors B and G. However, it supports up to 4 data streams, enabling speeds of up to 288 megabits per second with 20 megahertz channels. To achieve faster speeds, 802.11n optionally can support 40 megahertz channels. When 4 channels with 4 streams are used, 802.11n can reach speeds of 600 megabits per second. Due to overlapping channels in the 2.4 gigahertz, it's easier to set up 40 megahertz channels with 802.11n hardware that supports 5 gigahertz signals. So if you look at this chart here, or this image here, what this image is depicting, it shows you have 11 channels. Channels 1, channel 6, and channel 11 do not overlap with each other. Every other channel overlaps with each other, and this is what can cause interference, as I mentioned, when it comes to dealing with Bluetooth devices or baby monitors or microwave ovens, etc. Let's talk about the 802.11ac. So the 802.11ac, also known as wireless AC, supports only 5 gigahertz frequencies and achieves much faster speeds than the 802.11n 5 gigahertz by doubling channel width and supporting up to 8 data streams. 802.11ac wireless routers include 802.11n 2.4 gigahertz support, so that the older Wi-Fi 2.4 gigahertz and the 5 gigahertz standards can also connect to the router. And 802.11ac wireless adapters also include 802.11n 2.4 gigahertz support. So in this image here, you can see that the 5 gigahertz has way more channels for you to select from that do not overlap as opposed to the 2.4 gigahertz range. Let's talk about speed limitations. So there are a couple factors that affect Wi-Fi speed, such as the following. The greater the distance between an access point or a wireless router and a wireless client, the slower the speed of the connection. When wireless devices that support different speeds connect, they connect at the speed of the slower device. When network channel congestion is present with 2.4 gigahertz wireless networks, a single 20 megahertz channel may be used on an 802.11n compatible wireless access point, even though 802.11n supports wider channels. The more data streams connecting devices, the better the performance. Low-end 802.11n network adapters and access points and wireless routers typically have only one antenna and thus only one data streams. To determine the number of data streams a wireless in or wireless AC adapter supports, you can check its specifications. Some wireless adapters display this information in the Windows Device Manager. Let's talk about interference and attenuation factors. So interference and attenuation are two factors that make older versions of Wi-Fi, such as 802.11b, A, and G, much less desirable than the current versions. So let's talk about interference real quick. So interference is caused by devices that are operating in the same frequency as the wireless network. So for example, if channel 3 is used for your 2.4 gigahertz wireless network, a nearby network using channel 2 or channel 4 would interfere with your network, and your network would interfere with theirs because of the overlapping problem with 2.4 gigahertz wireless networking. Other devices that can interfere with the 2.4 gigahertz network include some types of cordless phones, some wireless mice and keyboards, early versions of Bluetooth, and some types of home automation devices. Some 2.4 gigahertz wireless routers and access points use automatic configuration of channels in an attempt to avoid other nearby networks. Free and paid network analyzer apps for computers and mobile devices can be used to determine the channels in use in a nearby network and help you select a channel manually. Let's talk about the benefits of using 802.11c. So one benefit of using 5 gigahertz networking, such as 802.11ac, is the greater number of usable channels and the reduction of possible interference from other devices. Because the channels do not overlap and because 802.11c supports the ability to use non-adjacent channels, where you have two 40 megahertz channels or an 80 megahertz channel, 802.11ac provides faster throughput with easier configuration than 2.4 gigahertz wireless networks. Let's talk about attenuation. So attenuation is the loss of signal strength in networking cables or connections. This typically is measured in decibels or voltage and can occur due to a variety of factors. It may cause signals to become distorted or indiscernible. An example of this is Wi-Fi signal and strength getting noticeably weaker the further that your device is from the router. In wireless transmission, attenuation could be caused by objects in the path of the signal, such as doors, walls, or trees. Another issue with older standards, such as the 802.11b, A, and G, is the problem of signal reflection. Signal reflection off objects arrive at a wireless adapter or router at different times, causing lower signal quality. And this problem is also referred to as a multi-path fading. 802.11n and 802.11ac are designed to take advantage of multi-path signals to improve performance. These versions also support MIMO, stands for multiple input and multiple output antennas, to improve performance. Some 802.11ac routers add a feature called MIMO, which is multi-user MIMO, to more efficiently allocate network bandwidth among multiple devices. Some 802.11ac routers also use a technique called beamforming to set up a directional signal between the router and a specific client device rather than just using 360-degree broadcast signals. The easiest way to mitigate weak signal strength and attenuation issues is by simply moving the router to a location central to the devices that connect to it and locating the router on a wall or ceiling away from obstructions such as furniture. Let's talk about best practices. So here are some best practices when setting up a wireless network aside from just securing the network. First thing you want to do, you want to change the SSID. You want to change the default password, and you want to understand encrypted versus unencrypted networks and how to make encrypted networks as secure as possible. These changes can be made in two ways: by logging into the router or the access point manually using the device's built-in web server, which you can see the device's documentation for complete details, or you can achieve it by running a setup app included with the device. A third method of setting up security, which is known as Wi-Fi Protected Setup, or WPS, is no longer recommended due to it being easily hacked, especially if it is implemented by pushing a button on the router or access point to start the setup process. All right, let's talk about changing the SSID, or the service set identifier. So brand new out of the box wireless routers and access points typically have a device wireless network name, which is called a service set identifier, that is already configured and identifies the brand of the device and sometimes the model number. This information is broadcast to all devices near the router or access point. If you don't change this information, a hacker could look up the default settings and try to gain unauthorized access to your network. The SSID should be changed to something that does not identify the brand and model of the wireless hardware that you are using. It doesn't specify your family name or location. And finally, it does not reveal any personally identifiable information, also known as PII. Some vendors now require users to change the admin name and password and create a custom SSID as part of the initial setup. An example of a safe SSID would be something like 4TU843SKQ. And the reason that would be considered secure is because it uses random characters and numbers, not secure, but safe. An example of an unsafe SSID would be something like Smith 760 West or 760W. So basically it's saying if the Smith family lives at 760 West, this SSID makes finding their home easy. And another unsafe example would be Johnny's Wi-Fi, which is probably not in your best interest to put your name in your SSID. And the picture you're looking at here is once you log into the wireless router or the wireless access points management system, you would have an option to change the name inside of there. Let's talk about disabling the SSID. So your wireless router might also offer the option to disable the SSID broadcast in order to make the network hidden. To connect with a hidden network, the user must have its SSID as well as the password. Although enabling this option might seem to improve security, your network can still be detected with a network scanning app. So disabling the SSID basically means that your network is not broadcasting your SSID. So if you turn on your phone and you start searching for networks to find, it's not going to advertise your network. It'll be essentially, quote unquote, invisible until somebody breaks out a network scanning app. All right, let's talk about changing the default password. So changing the default SSID is a start to protecting your Wi-Fi network. More importantly, you should change the default password to prevent unauthorized access to your Wi-Fi network. Unfortunately, a lot of wireless router and access point manufacturers list the default username and password to their devices in their documentation, and that documentation is often available online for free. The popular choice for a default username is often admin, and the popular choice for a default password is often admin or password, or there's no password at all. So change the management password to a non-obvious phrase. Some routers can be managed wirelessly, which means that an attacker could change its settings and take over your network without even seeing your router. If your router has an option to use a wired Ethernet connection for management, enable this option, disable wireless management, and then change the default password. Now, you guys will be surprised as to how many people have wireless networks who do not change the username and passwords at all, which enables anybody driving up and down the street to find their SSID and just log into their router and get the cruising the internet all willy-nilly. Let's talk about unencrypted networks. So a wireless network can be set up to be either unencrypted, which means it's open, or encrypted. And we will discuss the various options below. So you have an open network. So an open wireless networks are just that. They are open. They have no encryption. Anybody with a smartphone, laptop, computer, tablet, or some other networking device could simply just connect to the network. Open networks are popular in hotel lobbies, restaurants, and coffee shops because there is no connection management needed. Unfortunately, an open wireless network could be easily exploited. People looking for illegal downloads or visiting other illegal websites like to use open wireless networks to grab the data they want. Tracing the connection from the illegal site back to the wireless network does not show who was using it. If your wireless network is open, you could be blamed or arrested, depending upon what was done. Let's talk about a captive portal. A captive portal is a web page accessed with a web browser that is displayed to a newly connected user or users of Wi-Fi or a wired network before they are granted broader access to network resources. Captive portals are commonly used to present a landing or a login page, which may require authentication, payment, acceptance of an end-user license agreement, acceptable use policy, a survey completion, or other valid credentials that both the host and user agree to adhere by. Captive portals are used for a broad range of mobile and pedestrian broadband services, including cable and commercially provided Wi-Fi and home hotspots. A captive portal can also be used to provide access to enterprise or residential wired networks, such as apartment houses, hotel rooms, and business centers. A captive portal is not a secure connection. However, if the terms of service listed are enforced by the network configuration settings, for example, settings that block the use of keyboard loggers or remote control apps, it is slightly more secure than an open network. Let's talk about encrypted networks. So, wireless security encryption works like this. When you select an encryption standard, you assign a password, also known as an encryption key, that users must provide before they can connect to the wireless network. There are 3 different types of encryption that you can use for a Wi-Fi network, and those 3 types are WEP, WPA, and WPA2. Let's talk about WEP, or WEP, also known as Wired Equivalent Privacy. And this was the first type of wireless security developed. WEP was introduced with the 802.11b and the 802.11a wireless networks. When WEP was first introduced, the password could only be 10 hexadecimals or 5 ASCII characters long. The password was encrypted with a 64-bit key. Later, WEP devices started using 26-character hex or 13-character ASCII passwords that were encrypted into a 128-bit key, which makes it, slightly harder to guess. Some types of corporate network hardware support 256-bit encryption. This can only be used if all other devices on the network also support 256-bit encryption. WEP keys generally are based on hexadecimal values, characters 0 through 9 and letters A through F, although some devices can use decimal values. The limited character set, short key length, and weakness in how WEP authentication takes place have made WEP obsolete. It was supported by 802.11g, but not by later versions. Next, we have WPA, a more powerful encryption standard called the Wireless Protected Access, replaced WEP with the introduction of 802.11g. Software and firmware updates were made available by vendors for the older 802.11b and A devices to add WPA support. WPA also uses a pre-shared key, also known as a PSK, but unlike WEP, the key can be of a varying length, up to 63 ASCII characters, including punctuation. The original key is used as the basis for frequent changes, and it is encrypted using a temporal key integrity protocol, or TKIP encryption. TKIP has many features that make it stronger than WEP. Let's talk about WPA2. So Wireless Protected Access 2 is an improved version of WPA. WPA2 uses the even stronger Advanced Encryption Standard, or AES encryption technology. When possible, use WPA2, which is also known as WPA/AES, on your wireless network. If your wireless router or access point has WPA or WPA2 setting, it can support either type of encryption on the same network. Use this option if you have devices that support WPA but do not support WPA2. So here you're looking at a screenshot for when you're going to be setting up your router, and it's going to give you an option to select security mode. It is in your best interest to select WPA2 because it offers the strongest security for your wireless network. And here is a chart giving you the comparisons between Open, WEP, WPA, and WPA2, everything that I just discussed. You can find this on my website where this current class is located. And that's it. So let's talk about discuss some check on learning, shall we? So first question. How many non-overlapping channels are available on a 2.4 gigahertz Wi-Fi network? How many non-overlapping channels? Would it be 11? Would it be 12? Would it be 3? Or would it be 4? How many non-overlapping channels are available on a 2.4 gigahertz Wi-Fi network? The correct answer would be 3. 3 channels are available. That would be channels 1, 6, and 11. So when you guys are setting up your Wi-Fi routers, it's going to ask you to select a channel. If you're using a 2.4 gigahertz frequency, select either channels 1, 6, or 11 because you will not overlap with any other channels, which could cause potential interference issues when you're using Wi-Fi. So, next question. If you set up your wireless router to require characters to be entered by a user who wants to connect to the network, this is an example of what? Is it PSK? Is it USB? Is it a captive portal? Or is it 802.11g? So they want to access your network, but they have to enter some characters to get access to it. This is an example of what? It will be an example of PSK, or a pre-shared key, or essentially a password. Final question. Which of the following is the correct order from most vulnerable to most secure for encrypted wireless networks? Would it be WPA, WPA2, and WEP? Would it be WEP, WPA, or WPA2? Would it be WPA2, WEP, then WPA? Or would it be Open, WPA2, and WEP? So from the most vulnerable to the most secure, which selection is in the correct order? The correct answer would be WEP, WPA, and WPA2. Though that will be going from least strongest to most strongest is essentially what that is saying. But always remember, if you have the option to select WPA2, select WPA2. If you don't have the option to select WPA2, select WPA. By all means, avoid WEP. All right. So in summary, we have talked about basic wireless networks, where we have went over how to install, configure, and secure a basic wireless network. For more information on this, please visit my website, Technology G, so you can get read up on the latest and greatest to help you successfully pass your CompTIA IT Fundamentals Certification exam. And until next video, peace.